While we begin our discussion on table saw safety, I always like to start my talk with this quick demonstration. I think it's one of the most important lessons you can learn when in a wood shop, and I try to begin all of my safety lessons with this demonstration. It brings home a point that's just very important to you and something that you need to remember whenever you enter the wood shop. So I'm going to do a quick, simple, slow cut and just let you see what it looks like when making a cut on the table saw. Now, if you were in my classroom when I did that demonstration, what typically happens is this is the first time people have seen a cut on the table saw, and they lean in real close as I look like I'm going slow and steady through the saw. I tell everyone to pay attention, and then I slam that thing through the table saw blade as fast as I can. And this is the lesson that I want everyone to take note of. When I cut that board, I use a board that's about 2 finger widths across, just to make a point. If you look on the other side, that represents the piece that was cut off. And I like to point out that that could easily be your fingers. As fast as you saw that thing cut through this board, it could cut through your fingers 5 times as fast. It's very, very important when you're in the wood shop to always remember this lesson. This is the most important lesson you'll ever get when you're in the wood shop. And that is that you can never take safety lightly. You can never take the chance of getting cut, because in the blink of an eye, even faster, that could be your fingers sitting there on the table. And all of us want to keep our fingers. We want to leave the shop in just as good of condition as when we got into the shop. I like to start all of my introductions to the woodshop class with that demonstration. It very quickly brings home the point that the woodshop is a very dangerous place. It's something where just a second of inattention could result in a terrible accident. And that's why this lesson needs to stick home with you. You need to incorporate this into your permanent brain so that whenever you're in the woodshop, you're always working safely. You can never take a chance on anything bad happening, because something can go bad so quickly in the wood shop and cause so much damage. So even though this is probably the most fun class in school, it's a class where you easily get lost in your own mind and the fun that you're having, building things, making things, taking things out of your imagination and bringing them into the real world. It's so fun to do that. But at the same time, you always need to remember this lesson. And it's something I show every single student that comes into the shop, because I want them to realize how quickly something can go wrong. And in that brief amount of time, your life can be forever changed. So every one of these tools in here can be used safely. You'll notice I have all 10 of my fingers. I've made tens of thousands of cuts in the shop. But you must always do everything safely. And the whole point of this video is to show you how to use this tool safely. So I don't want this to scare you in the sense that you feel that all tools are dangerous and that you can never use them safely, because that is not the point of this operation. The point of this is just to show you that bad things can go wrong, and you are your most important advocate for safety. You are the one that controls your own destiny in the shop. You are the one operating the tools, and it's important that you remember, I am in control and I am going to use every tool safely. I'm not going to cut any corners. I'm not going to rush, because if I do, in one split second, my life can be forever changed. And that's why I think this is the most important lesson that you'll ever encounter in a wood shop, is this, because things happen bad very quickly. I always try to show in my presentations how kickback happens, what causes it, and how to avoid it. And this can be the result of kickback. So again, I will show you how to use every tool safely. Every tool in the shop has been thoroughly gone through by engineers. It's been tested, it's been reviewed, and most of these tools have been around for sometimes over 100 years. And the design has been refined throughout all of that time. All the accidents that have happened on tools have made input for the engineers to redesign everything. And all of these tools can be used very safely as long as you and I follow all of the safe operating procedures. That's what we're going to get into now, so I hope you'll stick around with me and I'll show you how to use this tool very safely. As with all tools in the shop, the most important thing when discussing safety is keeping boards up against the guides. Every single tool in the shop is going to have a table, and we want the workpiece to stay flat against that table at all times. Whenever a workpiece is allowed to move freely is when you're going to invite kickback. So we want to make sure that we keep this thing flat against the table. The other thing is we want to keep it flat up against the miter gauge. So by doing those two things alone, we will probably eliminate 99% of the accidents. If we could just guarantee that this workpiece would stay attached to this guide, it would eliminate almost all problems. Unfortunately, we can never guarantee that in the wood shop because there may be hidden stress in this board, there could be a nail embedded in it, there could be a rotten spot in this board. All kinds of things can come into play that we may not be able to guarantee this board stays against this fence here. So when we keep this against the fence of the miter gauge, we want to make sure it stays tight up against there. So when we go to cut this, we need to keep it flat against the table, flat up against the miter gauge. The best way to do that on a miter gauge is to make sure you anchor your thumb to the miter gauge. We do not want our hands ever leaving this miter gauge. The miter gauge is locked into the table. It's in this slot here, and it can't even lift out because there's a piece in the front that keeps it in. So if we keep this locked down, we can guarantee that our hands will stay anchored to this. And that's what we want to do. We never want to have our hands floating up on this board like this, because if this board gets grabbed, our hand is going to go with it. So we want to anchor our thumb at least to this miter gauge. Okay, that will be on the metal of the miter gauge. Sometimes you'll have a sacrificial board here. Anchor to the metal, thumb to the metal. When you hold this board down, we want to hold it down into the table and we want to hold it back. So what I like to do is push one finger down on the table and then squeeze it back with my hand. And the idea is that if this board suddenly gets sucked out of the miter gauge, that my hand is already squeezing, and so that it will more likely anchor myself to the miter gauge. Okay, that's a very important concept. And when I talk about our levels of protection and having multiple levels of protection at all times, this is one of them, and it's also one of the most important. So keep your thumb anchored to the miter gauge and your hands are always squeezing back into it. Just in case something goes wrong, that will make our own human slowness work to our advantage, and we will keep our hands safely attached to this anchor point that is stuck in the saw and will not allow us to go into the blade. So again, flat on the table, flat up against the fence of the miter gauge, and we're going to squeeze this thing back. Okay, we're going to hold it down and squeeze it back, thumb anchored to the miter gauge. In case something goes wrong, the natural reaction of our hand is going to be this. Okay? I don't even need to react. That's just my natural reaction because that's what I'm doing. The next guide that we need to discuss is the fence. And the rip fence can move left and right to give us a varying width of cut. When we're using the rip fence, the same exact rules apply. We need this board to stay flat on the table. We also need it to stay flat up against the fence. If we could guarantee that, again, it eliminates 99% of the problem. Okay? Since we can't eliminate it, we're going to have to use multiple layers of protection. But let's try to examine this fence and see what the natural reaction of wood is when I push it. So if I push this board into the blade, you'll see how the board starts to come away from the fence. And as we continue to push through, the board will get farther and farther away from the fence. That's the natural tendency of the board, and that must be stopped. If we do not stop that, this board is going to go into the blade and get kicked back. We'll talk about that in a second. But for now, I just want you to understand, you must fight that natural reaction of the board. You must push it against the fence. You must push it flat on the table. There are various ways to do that. We will discuss how to do that when we get to the portion on actually cutting. But you must keep it against the fence and flat on the table. Again, I'll show you how to do that at a later portion of the video, but for now, that's the most important part of using the fence as a guide. Flat against the fence, flat against the table. Another important concept regarding safety involves the height of the blade. So we already learned that the blade could be adjusted with this handle in the front, and you can raise the height of the blade up and down. The ideal height of the blade is supposed to be 1/8 of an inch to 1/4 of an inch above the workpiece. And you'll get different messages from different sources on which one is the safest. So 1/8 of an inch is roughly right around there, just a very small amount over the workpiece. Okay, that's 1/8 of an inch. A lot of places say you should keep the blade only 1/8 of an inch over the workpiece. And the reason they say that is because it minimizes the amount of blade showing, so that if your hand were to be dragged across the blade, it minimizes the amount of damage that your hand would face, at least theoretically. Okay, so that's why they say 1/8 of an inch. I prefer the height of 1/2. Okay, and that would be to raise this blade so that it's 1/2 sticking over the top of the board. And the reason I prefer that over the 1/8 of an inch is simply this reason. It still keeps the blade minimized so that if your hand went over it, it's not exposing a lot of blade to your hand. But I think it's a little bit safer because of this phenomenon. So let me lower it back down to 1/8 of an inch. So what happens when the blade is only 1/8 of an inch over is, as you'll cut a board, sometimes the boards aren't perfectly flat, or they'll warp during cutting, or you're putting pressure in slightly the wrong place. And what will happen is this board will raise up. Let's see if I could do it out of the camera. The board will raise up just slightly, and it usually only does it for part of the cut. So I will be cutting, and it will be perfectly fine going through the saw. But then there'll be a portion of this board that gets picked up just a little bit, or it's warped, and so it does not get cut. And then what happens is the whole thing gets snagged on the splitter behind it and creates an unsafe situation where you cannot push the board forward anymore and you cannot back the board out. So you're going to have to shut the saw off and start the whole process again. So I actually prefer to have this thing be 1/2 over the board, because it's a good compromise between keeping the blade low enough to keep your hands safe and also high enough to where the smallest of imperfections is not going to make this board get snagged on the splitter. Okay, so if it doesn't cut all the way through, it's going to snag on that splitter and create an unsafe situation. So for height of the blade, it's going to be anywhere from 1/8 of an inch to 1/2 over the board. I prefer the 1/2, which is about 1/4 of an inch.